Awesome algebra students. We're going to spend one more day talking about solving absolute value equations. This is our third day on this, so hopefully by now you're starting to feel pretty comfortable and confident with this. We're not really adding anything new today. We just want one more day to really reinforce this whole idea of how we solve absolute value equations. I'm going to suggest that you write down most of these problems, maybe not these first two because they are pretty basic, but I would still suggest that you're writing down problems as your examples to look at later. Number one is actually a really nice, easy one. It's almost too easy and people make mistakes on this. Remember what absolute value means. It's talking about the distance away from like the center of this absolute value function or from zero in this case, this n. The stuff that's inside the absolute value is 9 units away. So it can either be at positive 9 or that same stuff that was inside there can be at negative 9. In this problem in particular, the n's are already by themselves. There's nothing else to do. So we do happen to get two answers that are opposites. That doesn't happen very often, but it can. In number 2, we are not going to get just opposites. Okay, so we're going to start this problem by saying this stuff that's in the absolute value is 14 units away from the center of it. We're just going to say from 0 for right now. So I'm going to say x minus 10 equals 14. Or if we go in the other direction, x minus 10 equals negative 14. So these are not going to be opposite answers, but it's at least the same work for both of these equations. We're going to add 10 to both. So here I get that x is 24. When I add 10 here, I get that x is negative 4. And again, remember, we do need both answers. You can't just get one of them and say, oh, that's good enough. You can't get the first answer and then just change the sign and say the other one's going to be a negative 24 because it's not. When I check this, if I would put my values in here for the x, if I had the 24 right there, 24 minus 10 is going to be 14, and the absolute value of 14 is 14. If I put the negative 4 in there, then I would have negative 4 minus 10, which would be negative 14, but then the absolute value is still 14. In number 3, a couple of things. First of all, some people look at number 3 and automatically assume that it's going to be a no solution because I have a negative 9 right here. Well, the fact that the absolute value isn't by itself says that I don't really know if that's a negative yet. We can't do this if it is a negative, but we don't know that yet. Second thing is I cannot write my two equations until the absolute value part is all by itself. When it's by itself, then we can look at the two equations. So this is just an equation to get this absolute value thing by itself. To get rid of this negative 10, I would add 10. So I'm going to have that the absolute value of x equals 1. So this will work. And this is very much like the very first problem that we did. I could say that that absolute value stuff, that x, could be equal to 1. Or it could be equal to negative 1. And again, the x is already by itself. There's no other work to show. Those are my two answers, and they both work. In number 4, the absolute value is by itself. So I can write my two equations right away. My first one is going to be 3n minus 10 equals 7. The second equation, 3n minus 10 equals negative 7. Remember, the two absolute value bars tell you need two equations on these problems. So again, these will not be opposites either, but it will be the same steps in both problems. So I should be able to add 10. So I've got 3n equals 17. And then don't be upset. It's okay. We didn't make a mistake. Sometimes we just get fractions. We don't always get nice whole number answers. 17 over 3 for me is just fine. If you really want to change that to 5 2/3, you can. That would be 5.6 repeating. Make sure you write it repeating if you're going to do that, but I would rather stick with fractions on this. Second part of this, when I add my 10, now I've got 3 And then I'm going to divide by 3. So n equals 1. So that one happened to be a nice answer there. For this problem, I need to get the absolute value by itself before I write my equations. Okay? So for this one, I'm going to get the 7 away from the absolute value. Now that I have that, now I can write my two equations to solve. So I'm going to have 2x plus 4 equals 14. 2x plus 4 equals negative 14. So if I would subtract my 4, 2x equals 10. 5 is my first answer. So I would have a negative 18 right there. Do a keep, change if you need to. So there are my two answers for this problem. Before I move on to the last problem, because I only have one more problem left before we get to the work that you need to do on your own. If we ever have a problem like this, I'm going to just change my problem just a little bit so you can see something. If this had been a negative 7, when I added the 7s, I could get a 0 here then. And if that ever does happen, I want you to know that you would only have one equation because you don't have a 0 and a negative 0. That's not a thing. So we would only get one equation with one answer. That doesn't happen very often, but it certainly could today on the practice work. All right, here's our last problem. And this is as complicated as we're going to get. I need to get the absolute value by itself. We've looked at a problem like this before, and the way that I've explained it in the past is look at that absolute value like one giant variable. So instead of seeing 4 times this absolute value, pretend that this is just a really big x right here. So 4x plus 9 equals 53. What would I get rid of first? Well, the 4 is attached to it, so I'm going to leave that alone. So I would subtract the 9. So I'm going to have 4 times my giant variable, which I need to be able to read. $53 minus 9 is going to be 44. My alignment's all wonky right now, so I'm trying to adjust for that. So I'm going to get that my absolute value, 9 plus 5n, equals 11. Now I can write my two equations. And at this point, hopefully that's the easy part for you. So 9 plus 5n equals 11. 9 plus 5n equals negative 11. Subtracting our 9, I'm going to get that 5n equals 2. And we'll divide by 5. And again, it's okay that it's a fraction. That's going to give me that n equals 2/5. If you just took out a calculator and divided that, you would get 0.4, which would be fine as well. For the second equation, subtracting 9, be careful because you're going to have to do a keep, change. And again, I'm sorry for my alignment there. That's a negative 20. So I'm going to get that n is negative 4. So we get two different answers on there. Today's practice is going to be a worksheet. It looks very similar to what we've been doing. There's no big changes there. When you're all done with that, make sure you go and take the formative quiz in Schoology and let me know if you need any help.